Hello viewers, so we have this question that says a wave is described by y is equal to, so we're given the function and we're given say k is equal to 2.11 radians per meter, omega is equal to 3.62 radians per second, where x is in meters and t is in seconds. Determine the amplitude, wavelength, frequency and speed of the wave. Now, to determine what we are supposed to determine here, we need to understand the function that we are given. Now, for the displacement of a wave moving on a string, the general function is given as y is equal to a sine of kx plus or minus omega t added to the phase angle. So this is the general function that we have for the displacement of a wave moving on a string, where the a we are given is amplitude, k is wave number, x is position, omega is angular frequency, t is time, and this is the phase angle this side. So this is the general function that we are given, where negative and positive here, the plus and minus represents the direction of the wave. If it's going in the positive x direction, or rather positive y direction, we're using the negative, and if it's going in the negative direction, we use a positive. So the wave we're given in the question is basically moving in the positive x direction. That's why we have a minus sign there. So now let's analyze the function we're given. In the function there, we're not given the phase angle, meaning the phase angle is equal to 0. So this part is gone. Here we're using a negative because the direction is the positive x direction. All right. So from that function, we can tell to say whatever is written in this function, whatever is written before the sine function or before the trig function here, whatever is written before that is basically your amplitude. Whatever is multiplying by x is your wave number, and whatever is multiplying by t is your angular frequency. And whatever is added to these two here is your phase angle. So omega, the one multiplying by t, is angular frequency. Anything multiplying by x is your wave number, which is k, and anything that is written before the trig function is your amplitude. So the function we are given is, we are given to say y is equal to, we have 2.00 centimeters, then sine, here we have kx minus omega t. This is the function we are given. Now, as we can see, 2.00 centimeters is the one that is written before the sine function. So it implies to say what we have here is our amplitude. So for the first part where they're saying we need to determine the amplitude, the amplitude is basically equal to 2.00 centimeters. This is our amplitude in centimeters, or you can still report it in meters. This will just give us 0.0200 meters. So you can either report it as 0.02 meters or 2.00 centimeters. This is what we have for the first part. Now the second part is asking us to determine the wavelength. So how do we determine the wavelength? Now, given the information we have here, to determine the wavelength, we need to use the formula that says the wave number is equal to 2 pi divided by wavelength. So this is how we find our wave number. Our wave number k is equal to 2 pi divided by the wavelength. Making wavelength the subject of the formula, we find that our wavelength will be equal to 2 pi divided by k. Now remember, we're given the value of k and 2 pi is a constant, so our wavelength will be equal to 2 pi divided by k is given as 2.11 radians per meter. So all we have to do is punch our calculators. When we do that, what we are getting is, I'm getting 2.98 meters. So 2.98 meters is basically our wavelength. All right, so we have found our wavelength. The next one is frequency. We need to find our frequency. Now, how do we find our frequency? Our frequency can be found using the formula. Remember, angular frequency can be given by 2 pi multiplied by frequency. From this formula here, we can make frequency the subject, and our frequency will basically be equal to angular frequency divided by 2 pi. Our frequency will be equal to, we're given the angular frequency to be 3.62. This is in the units of radians per second, and this must divide by 2 pi. So all we have again is we need to punch our calculators and find our answer. All right, so according to my calculator, I have 0.58 hertz is my answer for frequency. So that's the frequency that we have for this wave, 0.58 hertz. All right, so we have determined our wavelength, we have determined our frequency. The next part is we need to find the speed of the wave. We need to find the speed of the wave. Now, which formula is going to help us find the speed of the wave? Let me get rid of this part here. All right, so for the speed of the wave, we're going to use the formula. Speed is equal to angular frequency divided by the wave number, where our V will be equal to angular frequency is given to be 3.62 radians per second, and this will divide by our wave number is given as 2.11 radians per meter. When I punch my calculator, 3.62 divided by 2.11, this is giving me 1.72 meters per second. So this is our speed, the speed of the wave. So we've determined our amplitude, we've determined our wavelength, frequency, and also our speed for this question. So that's how it is done. Subscribe to our YouTube channel, follow us on Facebook, and follow our TikTok page.